Okay, so now we're on the very last page of the review. Well, for the portion that we're going to cover right now, because the last part of it is the graphing, and graphing we'll cover on a later video, probably sometime next week. So find all zeros. 1 0 has been given. That's really helpful that one of the zeros has been given. So while you're working on a separate sheet of paper, we can actually fit a lot of this probably in this space right over here, because it already gives us a 0. So it already guarantees that, you know, the stuff that we were just doing on number 16 and number 17, that is true. So this is the stuff that we do with fundamental theorem of algebra. So this is the 2.6 stuff. So, you know, go over some of the work from there. Go over the video for 2.6. It's all in there. Okay, anyways. So since we already know this factor of x plus 2, we set it equal to 0. And that means that negative 2 is the number that's going to go in the corner. All right, so then we put 1x to the third, negative 12x. Wait a minute, we're missing an x squared, aren't we? So we better put a placeholder there. So we have 0x squared and then negative 12x to the first, negative 16 for our constant. And since this is a 0, what should we expect our remainder to be? We should expect it to be 0. Let's verify that that's the case. So we get 1 times negative 2, 0 plus negative 2, negative 2 times negative 2 is a positive 4, 4 minus 12 is negative 8, negative 8 times negative 2 is a positive 16. Okay, so we've already kind of factored out a part of this, all right? So we found one of the zeros already because it was given to us, negative 2. Now we have to find the zeros from this other expression right over here. So what does this expression translate to? Well, if we were to write it out, we have a constant value here, we have an x here and an x squared. So far we've got 1x squared minus 2x minus 8. So this is a quadratic, and we know how to solve quadratics for when they're equal to 0, which is finding a 0. By the way, that's what we're looking for, just the x values that give us 0. We already know a couple different ways to solve this. One way is through factoring. You always want to check to see if you can factor. If you can't factor, if you don't feel like you have that skill at your disposal, you can always just use the quadratic formula. So go directly to quadratic formula if you don't know how to factor. Either way, we're going to be able to solve this for our x values. So I'm going to do it, the easiest way I know, and that's to check factoring first. If that doesn't work, I'm going to go directly to the quadratic formula. And let's see here. So for this one, I need to find numbers that multiply together to be negative 8 and that add together to be negative 2. And those numbers actually exist. If I use negative 4 and positive 2, they multiply together to be negative 8 and they add together to be negative 2. So that means that this does factor. So this turns into, since we have a lead coefficient of 1, it's just 1x minus 4 for one of my factors. And then for my other factor, it's 1x plus 2. So if I set that equal to 0, now I'm just solving for the factors. So I set each factor equal to 0 to get my 0 values, or my x-intercept values. So I have x minus 4 equals 0. Add 4 to both sides, I get x equals 4. There's another one of my zeros. All right, x plus 2, I set that equal to 0 and solve. Subtract 2, I get x equals negative 2. That's another one of my zeros. How many zeros should I have in total? I should have a grand total of 3, because that's what the degree is. So I have negative 2, I have 4, and I have negative 2. So if I write that out, my zeros are as follows, because that's 3 of them, negative 2, 4, and negative 2. Since negative 2 shows up twice, we call that a multiplicity. So that means that we can write this out as 4 being one of our zeros, and also negative 2 with a multiplicity of 2. So those are all 3 of my zeros. All right, let's do the same thing with number 19. So number 19, they give us a 0, x plus 5. That's a factor of it. So that means that if we set it equal to 0, then that means that x equals negative 5. So negative 5 is going to be the number that goes up in the corner. But I noticed something on number 19 that I hope you might have picked up on if you looked at this problem before. If we have x to the fourth, x to the third, x squared, and x, all of these have x's in them. So what I'm going to do is factor an x out before I even begin. So if I do that, I get x on the outside of the parentheses. On the inside of the parentheses, I get x to the third plus 3x squared minus 18x minus 40. So I've already partially factored this. So that means that I can use this cubic expression with my synthetic division to whittle it down even more. In other words, to factor it even further. Because since I have a factor, just like what I had over here, I can set it equal to 0. And I already have another one of my zeros, x equals 0. So let's continue to work through this problem and find all the zeros. How many zeros are we supposed to have, by the way? We're supposed to have 4 because our degree is 4. So we already have one of them, and we're going to get a second one right over here when we prove that it is a 0. Okay, so we're going to use this cubic expression. So we have 1x to the third, 3x to the second power, negative 18x, negative 40 as our constant. Under our constant, that's where our remainder box is going to be, and it should be 0. Let's see if that's the case. So 1 times negative 5 is negative 5. 3 minus 5 is negative 2. Negative 2 times negative 5 is a positive 10. 10 minus 18 is negative 8. Negative 8 times negative 5 is a positive 40, and sure enough, 40 minus 40 is 0. Okay, so that's one of our zeros. We just found another 0, which is negative 5, which was given to us. Let's find the last two zeros. And wait a minute. Look at these. These are the exact same quadratic, aren't they? All right, well, that really doesn't help us out much because I was hoping that this would be an irreducible one, so we'd have to use quadratic formula, but, you know, we have x squared minus 2x minus 8 equals 0. We already solved it using factoring. Let's solve it a different way. Let's use quadratic formula. So if I use quadratic formula on any quadratic that I have left over, I will get solutions. My solutions, I even know. I should get 4 and negative 2. Let's see if that's what I get with quadratic formula. So my a value is 1, my b value is negative 2, my c value is negative 8. So plugging it into the formula, I get negative of b, negative 2, plus or minus the square root of b squared, negative 2 squared, minus 4 times a, 1, times c, negative 8, all over 2 times a, 1. All right, the negative of a negative is a positive, so I get 2 plus or minus the square root of. Let's see what this is. So, all right, if I just type that into my calculator with the parentheses, this is going to be really, really easy. So parentheses, negative 2 squared minus 4 times parentheses 1 times parentheses negative 8, and I get 36. Oh, that's a nice number to take a square root. So 36, and then in the bottom, that's 2 times 1, which is just 2. Okay, almost done with this. So we have 2 plus or minus, then the square root of 36 is 6, so we put 6 there. So this branches off into two different problems. We have 2 plus 6 over 2, and we have 2 minus 6 over 2. All right, so let's see here. 2 plus 6 is 8, so this is 8 over 2, which gives us 4. Hey, check it out, 4. That's what we had over on this problem right here. So 4 is another one of our zeros, x equals 4. There we go, just writing it up here. And now let's get our last zero, which again should be negative 2. Let's see if that's the case. So 2 minus 6 is negative 4, and negative 4 over 2 is, sure enough, negative 2. So that's our last zero, x equals negative 2. Let's check for any multiplicities. So I have 0, negative 5, 4, negative 2. That's 4 zeros, and none of them are repeated, so there's no multiplicities. And that's it. That's all that we have to do for this one. Okay, so that wraps up this part of the review. The next part is going to be the all graphing part of it. So I'll tackle that one in a separate video probably sometime next week. Okay, so that's it. If you have questions, make sure to go in for some extra help. That's it from my end. Good luck on your test. And I don't know. Wait a minute. I don't really believe in luck. No, not good luck. Let's just demand that you do well, or say something dorky like may the force be with you or whatever. But yeah, either way, try to kick butt on this one. You can do it. All right, bye.